Hello and welcome to the ACS to ISE migration video tutorial. This is part one of the three-part series that would cover the overview and the planning for the migration. In the overview, I would cover basic information about all the three different parts of migration, which would be the planning, preparation, and the migration. However, this video tutorial would be focused more towards planning section. There will be two more video tutorials that will be made for other sections. Now, ACS to ISE migration could be a very important and complicated topic as well. So please put your pen down and avoid taking notes. Please pay attention to all the details and information provided in this video tutorial. Now, this information is already made available in the how-to doc, which is also available in the community site, doc 65715. My name is Krishnan Thiruvengadam. I'm a technical marketing engineer from the Policy and Access team. Now, as I mentioned earlier, the migration consists of three different sections: planning, preparation, and migration. The planning would cover all the top-of-mind questions and information on how to design your topology based on your environment and your device administration model, and how to convert your ACS deployment to ISE deployment. The preparation would cover all the nuances related to tool, and it'll also give you information where to go in ACS and ISE to actually configure or monitor the success of the migration, the location of the configuration, and any exceptions that come up in the migration. You can go and fix it. It'll provide all the details of that, and it'll also cover information related to staging your environment. The migration part would cover the actual migration process that includes the migration tool. An overview of the tool will be given, and it'll cover three sections: exporting the data from the ACS, analyzing the data for any policy gaps, and importing the data to ISE. All these three sections would be covered in the migration. And finally, how to verify your configuration that has been migrated. The first and top of the mind question would be, what do I need to know to migrate my ACS deployment to ISE? This video tutorial would be covering in detail all the basic information that you need to plan the migration. So as you see here, ACS feature comparison on the migration path has been asked many times by many people. So they need to know what is a feature comparison and what are the underlying hidden differences that it's not perceptible. For migration path, people ask questions all the time: how do I migrate my 3x or 4x ACS deployment to ISE? Or how do I migrate 5x to the later version to ISE? And for people who are new to ISE, I have included the deployment consideration section that will give you the differences between ACS and ISE deployment. Now, having known all these basics, then we will take a deep dive on the topology design, like if you have TACACS and if you have radius, based on the device administration model and based on the performance metrics of TACACS as well as radius. There will be deployment options provided, dedicated deployment, or you can have dedicated PSN'S with shared PAN and MNT. So once you learned how to deploy your ISE and how to move your ACS to ISE deployment based on your environment and the device admin model, then we will see how to scale your PSNs and things that you need to know to scale your PSNs. Say if you have a certain environment and we need to know what hardware you need to use and how many PSNs you need for radius and TACACS, all this information would be provided. And finally, how to do your MNT sizing based on your log needs. Right? You need to size your hard disks, and you need to order hard disks. You need to order certain platform or appliance or VMs, right? And you need to, it'll provide all the information related to us. And then finally, we will summarize what we learned from this video tutorial. So the first topic in the planning section is the ACS to ISE feature comparison. Thomas Howard has created a nice community link for this topic. And I have updated this page with the latest and greatest information that is already available in the how-to guide for migration. So this link would be the go-to place for any ACS to ISE feature comparison. Let us briefly look at the different sections before we actually open up the community page. The limits would be talking about the deployment limits. The feature section would compare the underlying features listed here between ACS and ISE. This would include ACS 4.2, ACS 5.7, ISE 2.0, and 2.1 for the features listed below. Let us take a closer look by clicking on this link. The limits would provide a comparison chart of deployment limits between ACS 5X, ISE 2.0, and ISE 2.1. From the table, you can see that the maximum number of nodes supported in a deployment for ACS 5X would be 22. For ISE 2.0 and ISE 2.1, it is 44 and 54 respectively. There is a big difference between the number of endpoints supported in ACS 5X and ISE 2.0 and 2.1. ISE 2.1 supports up to 1.5 million endpoints. As for the number of users, ISE 2.1 supports up to 300,000 users and has a parity with ACS. When you look at the number of network devices supported, it's 100,000 in ACS, and it is now 100,000 in ISE 2.1 as well. The number of network device groups still need to be looked into, and we have brought this up with engineering as well. In ACS, it supports up to 10,000. In ISE, we support up to 100. Those are the important ones worth mentioning. For other features, please take a look at the community link. Let's go to the feature parity, feature differences. Right, in Radius, all of the features are now supported except for leap proxy. Leap proxy will never be supported. For TACACS, IPv6 is not in, and that might come in the later release, and it's not being planned for the next release. In identity stores, we are planning to support LDAP server specification per ACS ISE instance in the next ISE release. So in the internal user and administrator section, most of the functionality has already been supported, and the user change password utility is brought up, and it is one of the features that's not planned for the next release. Group mapping will never be supported because this functionality can be configured using inline authorization condition in the authorization policy. Network access restrictions is planned for the next release. Configurable radius ports is planned as well for the next release. So does the maximum concurrent session per user group. Logging to external DB may not be necessary because we are planning to enhance the logging capacity of ISE in the next release for radius and TACACS and make it more dynamic. And these are all just planned, not committed. So this goes with a caveat saying that please don't bring it up if it is not in the next release. And these are the things that was brought up based on customer feedback and feedback from partners, and this has been planned. RSA token caching, that is planned for the next release. Dial-in attribute as well is planned for the next release. User-defined attributes for endpoint is also planned for next release. So let's go back to our presentation. We will be covering performance a little later in this video tutorial, once we cover the top of the mind questions and some of the deployment options. So the next thing in your mind would be, okay, so I know now what is a feature parity and the differences between ACS and ISE. What are the hidden differences and which are not perceptible, right? One of the main differences is that ISE has tighter name validation, which means a valid name can contain alphanumeric, hyphen, and underscore, a typical valid name. A complete list of ACS configuration and its equivalent in ISE, along with the naming constraints and how to fix it, is provided in the preparation section of the how-to guide for the ACS to ISE migration. Right. Here, if you see in this example, and this is a screenshot from the migration tool itself, the users have special characters such as /, which is not supported in ISE. So does network devices. For the network device, we don't support special characters. However, dot is supported in ISE 2.0 patch, one of the patches, and in ISE 2.1 as well. This information is also available in the configuration maps, and you can look at the configuration maps in the preparation section of the how-to guide. The authorization profile and other objects that are part of ACS will also have different naming constraints in ISE. Let us continue our discussion of hidden differences between ACS and ISE. Custom condition. This is implemented in ACS in the form of a button in the identity and the authorization policy. However, in ISE, the implementation is totally different. You have authentication and authorization condition, which is part of the regular inline policy conditions. Right? You can open it and take a look at the different attributes that are supported in ISE and take advantage of that and create custom condition based on that. Policy format. This is in fact in a tabular form in ACS, and it also supports hit counts. So if a traffic hits a certain policy, then the hit count increases. This is not available in ISE. The hit counts are not available. The policy tables are in a slightly different format. It's not in the format of tables any longer. Network conditions, also called network access restrictions. This feature is planned for the next release of ISE, and this can be created as part of the authorization condition using different attributes of ISE. Let's take a look at some of the unsupported rule elements in ISE a little bit once we understand more about the top three. So let's first talk about the custom condition, right? So in ACS, if you actually go to the authorization or the identity policy, you can see that there is a customize button to the bottom right corner. So when you click on this customize button, you will be able to customize the condition and move the condition from left to right so that these appear in the tabular column above. It also shows the hit counts in the same tabular format. Let's take a look at what ISE provides in a little bit. But before that, we wanted to remember that these conditions will have a comparable condition in ISE. The condition that is highlighted here are AD1 external groups, network device group using device type, and was machine authenticated. Let's see how to create these conditions in ISE using inline condition. So in ISE Authorization Policy, you go to the policy set, and you can see that these conditions can be created inline. AD1 has external groups, and you can also see the was machine authenticated equals true, and the device type equal all device types. So these are the conditions that are already available in ISE, and ISE has tons of attributes as well. You can take advantage of the number of attributes in ISE and use that to customize your inline conditions. Now, as part of the unsupported rule elements, there are a couple of things that you might need to know. In ACS, ACS provides a combinatorial operation of AND and OR. You can also group them. So you can see that the internal group users or NDG location is grouped, and the internal users using user identity groups is grouped again. So both these groups are combined using the AND operator. In ISE, so far, we only have either AND or OR. However, this might change in the future, and we have plans to include the combinatorial operations in the next release. ISE also does not support date and time in its policy condition. There are other unsupported operators in ISE that are supported in ACS. For example, in ACS, you have in, not in, contains any, and contains all. This could be replaced with starts with, not starts with, equals an OR, and equals an AND. So if you actually look at the drop-down box in the condition for the authorization policy, you can see the different operators that are supported in ISE. Fantastic. Now that we have covered the feature comparison as well as some of the hidden differences, that would answer the top of the mind question for anyone, right? The second question would be, what is the migration path? And if you're migrating from the later version of ACS or the older version of ACS, right? So ACS 5.5 and 5.6 can be migrated to ISE 2.0. ISE 2.1 supports migration from all the last 4 versions of ACS. Now, if you are using an older version of ACS, ACS 3X or 4X, I have a blog which is created in the community site, and you can go to the community site and type in ACS to ISE migration. You will see the page, and if you want to migrate ACS 3X and 4X, then please take a look at this blog. This will actually give you insight on whether you want to migrate or whether you want to do a clean install. Whether to upgrade, migrate, or to do a clean install is always a big question, especially if you are using an older version of ACS. So if you want to migrate from ACS 5X, 4X to ISE 2X, you always have to recommend the best possible option to the customer given the nature of the customer environment and the complexity. So if you are migrating from 5X to 2X, it is actually a 2-step process. You have to migrate, or I'm sorry, you have to upgrade from ACS 5X to 5.8X, which is the latest version of ACS. I would recommend ACS 5.8X because that is the only version that is active out there. All the other versions of ACS, the BU have announced end of life. So once you upgrade over, then you have to migrate from ACS 5.8 to ISE 2X. So it's a 2-step process. If you're using a slightly older version of ACS, you have say ACS 5.1 or 5.2, then you need to do an interim upgrade to an ACS 5.4 and then upgrade over again to 5.8. If you are using ACS 4X, I would recommend a clean install. ACS 4X to ISE 2X is a two-step process migration. You have to migrate once from ACS 4X to ACS 5X, and then you have to migrate from ACS 5X to ISE 2X. There are big architectural differences between ACS 4X and ACS 5X, and ACS 5X has policy differences between ACS and ISE. In ISE, the policies are flat. In ACS, the policies are more hierarchical. So there is no guarantee that the data would be carried over between these two migrations. So the advantages of time savings and cost outweighs other concerns, such as the system is being older, or they have undocumented configuration, or the system is not being touched for a long time. Right? You can also take snapshots of the UI, the ACS UI, and use this to configure ISE from the scratch. So clean install is the best path going forward if you're using ACS 4X to ISE 2X. Having discussed about the migration path from ACS 5X and ACS 4X, the next obvious choice would be to talk about the end of life consideration, so that customer can upgrade to the latest version of ACS before migrating to ISE. Now this chart would give you the end of life information. As I mentioned earlier, 5.8 is the active version. All the other versions we have announced end of life, and you can see that most of the version is end of sale, and some of the older versions 5.5 and below is end of life. The oldest version 4.2 and 3 are end of support as well. So if you have customers on 4.2 and 3.3, please migrate them ASAP. That's mainly because ACS 4.2 is supported in a very old version of Windows platform, which is not supported by Microsoft, and it's open to all different vulnerabilities out there for the Microsoft operating system. So please migrate them over ASAP. Now, having talked about the top of the mind questions, let's talk about some of the deployment differences between ACS and ISE. And this is for people who are new to ISE, right? And they have already an ACS deployment, and they want to know how to deploy ISE. Now, ACS has a primary and a backup setup. Similarly, ISE also can have a primary and a backup setup for redundancy. However, all the functionality are separated in the form of personas in ISE. So you have the administration persona, monitoring persona, and policy services persona. All these three personas can be in the same box or can be split into different boxes in the sense different individual boxes of ISE. So the admin persona takes care of the administration and management and configuration, and it synchronizes with all the different personas or the nodes in a topology. The monitoring is mainly meant for logging and troubleshooting. The policy services, we call it a policy services node. The policy services persona is the heart of the ISE deployment, which responds to your radius request and the TACACS request. It also speaks to your Active Directory LDAP server for authentication. It talks to your external identity store. All this is performed by the policy services node. So that is the workhorse of your deployment. So ISE can be deployed in different ways. One is a standalone, as we saw earlier. The second one is a basic distributed deployment. Say if you have two data centers, right, and you have a high speed link between two data centers, you could have in one data center an admin MNT node co-located And for redundancy, you can have a secondary node, and you can have a bunch of policy services node cluster. And this cluster is mainly useful. A cluster is a service that's within ISE and is mainly useful for better data replication. This is again useful for services such as profiling and everything. So all the different devices, different NATs, such as your ASA, your wireless controller, and your switches will talk to these policy services node, and the endpoints behind these nodes will be able to authenticate. So in case of TACACS, then all these devices would be managed, and the authentication server would be the PSN'S. So this is a fully distributed setup where you split your deployment and you have dedicated PAN and MNT, and you also have dedicated PSNs. You could have dedicated PSNs, or you could have shared PSNs between Radius and TACACS, which we will look at it in a bit. And there are latency requirements here. In ISE 2.0, the link latency is 200 milliseconds. In ISE 2.1, it is 300 milliseconds. This is specifically for Radius. For TACACS, it can be relaxed a little bit. So once you understand the ACS and the ISE differences, the next thing is, let's take a look at TACACS first, because a lot of ACS customers use the TACACS service. And the approach towards TACACS is two-pronged, right? One is human admins. I used to be a system administrator, and all I did before joining Cisco was logging into the network devices and performing certain commands and look at the results and make sure the results are valid. So those are human administrators. And for example, like, if you look at the performance for human administrators, say for 20 device admin running one device, one command per second, the performance would be 40 transactions per second. The next would be the scripted device admin. So if you have a large number of network devices, say 10,000, 20,000, 30,000, you might not be able to scale based on manually performing device administration. You need a scripted or programmatic way of logging into these devices. Many big customers use this scripted device admin model. And of course, there is a combination of human and scripted device admin, which a lot of large customers use as well. Now, having spoken about these two different models, let's take a look at what are the deployment options you have based on these two models. Remember, the deployment option is also based on the services you need for your customers, right? So there are two different services, Radius and TACACS. So the first question is, should Radius and TACACS coexist in the same deployment, or do you need separate deployment for Radius or TACACS? Right. The first model we will discuss is the dedicated deployment. The pros of the dedicated deployment is it offers complete separation of both the TACACS and Radius. And this is typically used in an environment where two different groups manage these devices, and it offers complete independence of managing these two. It also is used in an environment where authentication performance is a high priority, or if there is a high profile user needing quick access to network and you don't want your device admin to interfere with these high profile users. The disadvantages could be, if you have two different ISE deployment, then you have to incur additional cost to manage and maintain. And it also adds cost to have a separate PAN and MNT for your second deployment. Typically, bigger customers using scripted device admin model use this type of deployment because it gives complete and total cost of ownership. The second type, or the second deployment option, would be dedicated PSN. Now, this also gives centralized policy management. However, the PSNs are separate. The PSNs are separate for Radius and TACACS, and this is typically used where you have a combination of human admins and scripts. So if you use scripts extensively in your environment, use dedicated deployment, and if you use scripts sporadically, use dedicated PSNs. We will take a look at it later. We will take a look at it in a bit, how to choose a particular deployment. So the disadvantage of the dedicated PSN is that the per PSN utilization for Radius and TACACS could be low, or you might need additional PSNs based on the geographic coverage you need for your customer. The third deployment is the integrated deployment, where you share all the boxes, the PAN, MNT, and the PSNs for both Radius and TACACS. This is a highly optimized environment, and it offers high flexibility, and you have centralized policy and monitoring as well. And this is typically used in an environment where you do not have any IT requirements for authentication performance or network access specifically, and the separation of network access and device admin is not critical. So this is also used in an environment where human admin is mainly used, right? Typically in a small or medium-sized environment. So the disadvantage is that, like, if you have multiple departments or multiple business units managing both Radius and TACACS, you need coordination between them, and also you need to understand the load of network access versus device admin and make sure they don't interfere with each other. So having discussed the deployment option, the dedicated deployment, dedicated PSNs, and the integrated approach, right? The next logical question would be like, okay, so I know what I wanted to use for my customer, right? Like I have chosen a deployment model, say for example a dedicated deployment. Now I need to know how many PSNs I need. How many 3495s do I need to buy, or 3595s do I need to buy based on the performance, based on the device admin model? Now it is actually a simple three-step process. If you're using TACACS only, the simple and easiest approach is to replace one ACS with one PSN. This ACS, I mean, is the ACS that is used for authentication. However, if you want to understand the performance impact, and if you're an advanced user, and if you want to look at the performance metrics and customize your deployment, you have to calculate the transaction per second for the TACACS, and this is based on the authentication and authorization and so on. This information in fact is available in the how-to guide Appendix C, right? There are also tables in Appendix B that will provide details on how to calculate the PSN based on the transactions per second in Appendix C, right? So you have to use both the tables, first Appendix C and Appendix B. I'll give you an example in a bit. And if it is Radius only, right, then you have to use endpoints per PSN per deployment. And there is a performance and scale doc that is also available in the community site, and that is a beautiful doc, and that has all the information pertaining to ISE performance and scale, and that has information on deployment limits, authentication performance across the platform for TACACS and Radius, the log sizing, and all the other pertaining information. Now, let's take a look at TACACS first, right? Like from a performance perspective, and let's take a step-by-step approach. Now, what is TACACS? TACACS has 5 different events: the authentication, session authorization, session accounting, command authorization, and command accounting. Each event occupies a certain amount of syslog. Authentication occupies 2 kilobytes, and if you combine all of it, authentication through session accounting, it occupies 5 kilobytes. And command authorization and command accounting is per command once the session is created. So you can see that it can go up to 3 kilobytes. Now let's take a look at the use case, and let's take a look at an example. Now we have a use case of a customer with 30,000 network device. The number of sessions per day is 4. And the customer is using a scripted device admin model and uses 10 commands per session, right? So if you look at the message size, and it is 5 kilobytes based on the authentication, session authorization, and accounting, plus the number of commands per session multiplied by both the command accounting and authorization. So there is a little formula to it, and if you wanted to calculate the log size, it is the number of devices multiplied by the number of sessions multiplied by the message size, which comes to 4 gigabytes per day for 30,000 network devices. Awesome, right? Now we know the log size. We also have an idea of the nature of sessions and the number of commands, and probably we can calculate the transaction per second based on that. The next step is to determine the total load per entire deployment in transactions per second based on the device administration model. Craig Hibbs, our senior TME, has created a fantastic table that I will be using for this video tutorial. He already had shared this during the SCVT if you have attended the last one. Now this table would give you information about the average transactions per second, the peak transaction per second, the logs, and the storage used per day, right? And this is for both the human admin model, and this table is based on 50 admin sessions per day, and the device admin model based on 4 scripted sessions as we saw in the use case, and 10 commands per session. Now the table is split into 2 parts, and the first part in the top half is for the human admin, and the second part is for the scripted device admin. Now again, the table is divided into 3 different sections. So if you are using session authentication, authorization, and accounting only, then you'll have to look at this section of the table. If you are using command accounting only, then you have to use this section. If you are using the whole 9 yards, where you enable authentication, session authorization, accounting, command authorization, and command accounting, you have to use this part of the table. Going back to our use case, our customer was using 30,000 network devices, and for 30,000 network devices, if you turn on all the events and logs, the transactions per second, the peak transactions per second would come to around 2.3K, which is 2,300 transactions per second. Right, and you also see certain areas which are highlighted in red, and this means that if you have a logging requirement that exceeds a certain limit, then you will have performance hits in MNT. So this is typically between 2 million records to 2.5 million records, and if you have more, then you might need an external logging server such as Splunk or any other system. and you might want to have logs forwarded to these logging server and configure ISE based on that. Now, having determined the peak transactions per second, let's go back to the different models that we spoke about earlier, right? The dedicated deployment model, the shared deployment model, and see and determine how many PSNs you need, right? In a dedicated TACACS deployment, TACACS only deployment model, you can see that for 2300 transactions per second, you might need slightly more than 234.95. So you can see that the maximum dedicated PSNs, it can go up to 5 maximum PSNs, out of which 2 is recommended. And you can see the maximum TACACS sessions or transactions per second. The maximum is 5,000. However, with 2 PSNs, you can have up to 2,000 transactions per second. You have 3 choices here. You can go with the 34.95, which means you might need more than 2. You can go with 35.15. Again, you might need more than 2, maybe 3, right? And you can also go with the 35.95 in that case, and you can stick with 2 35.95s. Remember, when you are setting these things up, and also take into account the future needs and calculate your PSNs based on that. What we talked about is for the basic distributed model for ISE. If you go with a fully distributed with the separate admin and MNT nodes, then you can see that the 35.95 might fit the bill, with 2 boxes supporting up to 3,000 transactions per second. If you go with the 34.95, again, like, you might need more than 2 boxes. In a fully distributed deployment, exceeding 15 to 20,000 transactions per second will cause MNT performance hit, as shown in this table. There is also a reference given under this table that has full platform comparison. The table below gives you the scaling per PSN, and it also gives you an idea of maximum transaction per second support per platform. So for a dedicated deployment, based on this table, we need up to 2 or 3 PSNs depending on the hardware to support 2300 transactions per second for our use case. Now let's take a look at the shared deployment. So a shared deployment is where you share the radius and the TACACS services, right? In the shared deployment, you can either go with an integrated approach where this is shared in every box. The radius and the TACACS is shared in every box, including the PSNs. Or you can go with a dedicated PSN approach where you have dedicated PSNs for radius and TACACS. However, the PAN and MNT is shared, right? Again, this has 3 different options based on the deployment model of ISE in a standalone. By default, it is integrated model. So that's why the maximum transaction per second is 50. And you can also see the maximum radius endpoints supported. For 35.95, it is up to 20,000. In a basic distributed deployment where you have admin and MNT in the same node, for an integrated approach, it supports up to 5 PSNs. For a dedicated PSN, you can have 3 radius and 2 TACACS nodes, right? So you can see that for the 35.95, right, like you have 3 radius and 2 TACACS, which is supporting up to 20,000 radius endpoints and up to 1500 T plus PSNs, TACACS PSNs, 1500 transactions per second for the TACACS PSN. In a fully distributed approach, you can see that For $35.95, you can have up to 48 PSNs for radius and 2 PSNs for TACACS based on a simple calculation. Right, and it can support up to 500,000 radius endpoints. The maximum transaction per second supported in a dedicated PSN, TACACS PSN approach is 3,000. For our use case, and you can see that like in a fully distributed approach with the dedicated PSN will be a better bet. If we want to choose basic distributed deployment, as you increase the number of dedicated PSNs for TACACS, reduce the number of radius PSNs and the number of endpoints supported in your deployment. Right, so the $35.95 with fully distributed deployment fits the bill for our use case. Again, the table below would give you information how to scale your PSNs based on radius and TACACS transactions per second, and this is per platform, 3415 through 3595. This is fantastic, right? Now we have the clarity of the deployment option, and we also have the clarity how to scale our PSNs and what are the options we have and how many PSNs do I need. However, we've also seen that MNT takes performance hits if the log exceeds a certain limit. So configuring MNT for special logging needs and log retention becomes important, and that'll be our next step. How do I size my hardware for my MNT? This is again based on a few steps. First, you have to understand the number of sessions used by the customer. Say you need to talk to the customer to find what type of device administration model the customers use, whether it is a human admin, whether it's a scripted admin, and try to determine how many sessions they use per day and what are the commands per session, so on. That'll give you an idea what is the log sizing. And you also need to know if there are any radius services running and how many endpoints you use for the radius. Now once you have that, and then you have also determined what TACACS events you need. Right, like there are different events: authentication, session authorization accounting, command accounting authorization, and so on. So based on that, the log size might increase. So you need to determine that first. And you also need to have a knowledge of the customer audit needs, if there is any. Right? If a customer has an audit need of 30 days of log retention, or 60 days, or 365 days, whatever it might be, you need to know this information to size the MNT hard disks. And you can also supplement your MNT logging with an external syslog server if the logging requirements of your customer exceeds the limits as shown in the tables we've seen before. Finally, once you have clarity and answers for all the items that we discussed before, all the 3 items listed here, then you can look at the Appendix C in the how-to guide available in the community site for ACS to ISE migration. This information is also available in the ISE Performance and Scale Guide, the link for which is provided in this slide. Based on these tables and the reference material provided, you can calculate the hard disk size for your MNT. Here's an example. If you have TACACS and if you need a log retention of so many number of days, you need to use this table. For our use case, right, you have the number of sessions per day is 4, and for 30,000 network devices, and we have calculated the log size of 4 gigabytes per day, right? Now, based on that, and if you have a 30-day log retention need, the MNT disk size you'll have to choose is 1 terabyte. It's simple, right? So we have this beautiful table, and it presents everything that you need from a log retention, log sizing standpoint. We also have a log sizing calculator, and this is for advanced user. And you can see on the top, and there is a link for ISE MNT log sizing calculator, and you can tweak it, and you can use it to your own advantage. And this is also available in the community site, and you can download it, and you can use it for both Radius and TACACS. Now, this is for the scripted device admin model, where customers are using a programmatic approach. If a customer is using a human admins, right, you can see that for 30 human admins, right, the log retention capacity seems significantly higher than the device admin model, as you can see from this table. So, if you look at the log size for 50 admins, it is 85 megabytes per day. So for 30 admins, it will be approximately 52 megabytes per day, which amounts to 1.5 gigabytes per month. So our original scoping for the device admin model with 1 terabytes capacity will be sufficient to hold this as well. This is when we extend our use case that we discussed before, the customer use case, to support both device admin and the human admin model with a log retention capacity of 30 days. For the Radius log retention, and we also have a table. Let us make our customer use case a little more interesting. We had TACACS device admin and human admin model to the use case, and understood the log retention needs and the requirements for both. Let us add the Radius services to the mixture and look at the Radius log retention capacity and the needs for the customer. We have a nice table that describes that. This table shows the log retention in terms of days for a number of endpoints, right? The number of endpoints is there to the left, and this is across different MNT disk size. So for our calculation, if we use a custom disk size of 500 gigabytes as shown above, the maximum allocated MNT table space for Radius is 120 gigabytes. It is important to remember that the table space is not shared between Radius and TACACS, and both are independent. So the log retention needs and the MNT log capacity for Radius will not impact TACACS, and vice versa. Currently, the allocation of MNT table space is done statically. However, we are planning to make it more dynamic in the next ISE release. Right? So the log size per day is calculated using a simple formula here, and based on this formula, if you plug in all these parameters, adding Radius service to the customer use case that we were discussing with 100,000 endpoints and 30 days log retention, you need a custom disk size of 500 gigabytes. So let us summarize the customer use case that we have discussed so far. For a customer requirement of 30,000 devices with a scripted device admin model of 4 sessions and 10 commands per session, and maybe if you add 30 human admins with endpoints using Radius services in the backend, right? Like say if you have 100,000 endpoints, based on the discussion so far, the best design option is to go with a dedicated deployment model with ISE Basic Distributed Deployment, or a fully distributed ISE deployment. So the platform options for TACACS are 3 3495s or 3 3515s, or you could have 2 3595s, or an equivalent of hardware in case you are using VMs. In case of Radius, you need 5 3595s to support 100,000 endpoints, and you need up to 10 3495s if you're still using 3495s. Remember, 3495 we have announced end of life, and it'll be good to upgrade your customer over to 3595 platform. The MNT hard disk space, we have seen that we require up to 1 terabyte of MNT hard disk space. So there you go. We have designed the new ISE deployment. We also acquired a good knowledge about ACS to ISE migration basics, comparison of ACS to ISE in terms of features, in terms of underlying differences, what is expected, and so on. The next step is to prepare your environment, which means you need to set up your staging environment, install the migration tool, go through some of the processes, understand some of the migration tool requirements and needs, and that will be covered in the next video tutorial. Last but not the least, I've included some references for ACS to ISE migration. I've also briefly discussed about licensing, enough to get you started. The ACS licensing facts doc 64011 is a link reference to the community page that covers all the different questions that comes up as part of ACS licensing, including links for ACS ordering guides, also called bulletins. The ISE ordering guide will have information about the specific SKUs required for migration between ACS and ISE. If you open up the ISE ordering guide, the migration appliance ordering information would provide ordering details for physical and virtual Cisco ISE migration appliances. In fact, if you are migrating from physical to virtual or vice versa, it says that you can replace the existing legacy appliances on a one-on-one basis using the SKUs provided in table 4. So please take a look at the ISE ordering guide to order your migration SKUs. Essentially, for ISE, you require a device administration license for TACACS. It is a perpetual license per deployment. You also need a 100 base license. If you are using basic Radius AAA services with VPN, including .1x, MAC auth bypass, TrustSec, web authentication, including guest, you need additional base licenses based on the number of endpoints in your network. So you can see that the license package for device admin has required licensing for device administration, and you need to add on the base licenses, and this is tied to ISE appliance, SmartNet, and SASU support contracts. If you want to turn on other key ISE services such as profiling, BYOD, posture, PXGrid, and other services, you need additional licenses. So all this information is available in the ISE ordering guide. For the migration, you need to be aware of these 3 docs: how to migrate ACS to ISE, and that is the how-to doc that this tutorial is based on. There is a ACS to ISE migration community link, and that will provide some basic information on the migration. It's a very good link to use if you're just looking for answers to top of the mind questions. The ACS versus ISE comparison community link, doc 63901, would provide comparison between ACS and ISE on features, limits, and performance as seen in the start of the video tutorial. The ISE Performance and Scale is a very detailed web page that has information about ISE deployment limits and scale based on the number of endpoints, platform comparison in the form of tables, log retention and log capacity for Radius and TACACS in the form of tables as well, It also has protocol performance for Radius and TACACS and much more. It has links to the high-level design documents for ISE as well. This concludes part 1 of this video tutorial that covered planning section of the 3-part series for ACS to ISE migration. In the next 2 video tutorials, I'm planning to cover preparation and migration. Thank you very much for listening. For any questions, you can ask questions through the community site or create a discussion. We'll be able to answer via the community site. Good luck in planning your migration. Please look out for the next 2 videos for additional details about ACS to ISE migration. Thank you.